The lecture is a guide to understanding properties required for a good quality reinforcement steel. Steel is classified according to the content of carbon. Carbon is added in a very small proportion to increase hardness. As shown, the percentage of carbon in reinforcement varies from 0.25% to 1.25%. There are three types of reinforcement bars. The first is plain bars. These bars do not have any ribs on their surface. They are commonly used for stirrups. These bars contain very small amount of carbon. Cold twisted deformed bars. Torr. These bars are first hot rolled, then twisted. Twisting makes the bars stronger. Torr steel is not in use nowadays, as it corrodes quickly. TMT bars. Thermomechanically treated. These bars are produced through a hot-cold method that involves a sudden cold water spray on hot steel. Because the core of the bar is still hot, the water helps to temper the surface. The common sizes available are listed below. Bars less than 5 mm in diameter are classified as wires. Expanded metal. It is produced from solid sheets or plates of carbon, galvanized, or stainless steel. It is used for slabs where tensile stresses are developed on both the surfaces, top and bottom. It is very convenient to install. Most common size of weld mesh is 100 by 100 by 3.27 mm with density of 1.25 kg per square meter. Tensile strength. It is the most important requirement of the reinforcement. Higher strength will help to reduce bar sizing and will in turn increase concrete placement efficiency. Bond strength. It is the resistance of rebar to separate from concrete. As we need a composite structure, bond between concrete and steel is very important. A strong bond will help forces to spread easily. Strength produced by deformed bars, that is a TMT bar, is 3 times that of a plain rounded steel bars. Generally, there are 2 types of bonds between concrete and rebar: adhesive and mechanical. Adhesion bond is caused by curing of the concrete surrounding the bar. As concrete gains strength, bondage will be increases. Mechanical bond strength is that which is achieved by lugs and helical ribs on the deformed bars, or by hooks and kinks in the plain bars. Ductility. It is the ability to undergo plastic deformation before breaking. Carbon content control is important to ensure ductility of steel. The table shows the minimum percentage of elongation for various grades of commonly used rebar. Bendability. It is the ability to bend. During construction, reinforcement needs to be cranked or bent. The bendability reduces as diameter increases and larger number of ribs are provided. Weldability. Welding is for splicing reasons or to attach inserts. Fatigue strength. When structure is subjected to force, it may fail at a stress lower than the yield strength of the material due to repeatedly applied force. This property needs to be considered for high repeated live load, for example for a bridge. Corrosion resistance. Steel has to be protected against corrosion due to reaction with oxygen, moisture, and chlorine in the atmosphere or groundwater. It can be protected by providing adequate cover or by providing a protective coating on rebar surface. The protection against corrosion depends upon grade of concrete, quality of compaction, adequate curing, lower water-cement ratio, and adequate cover. Fire resistance. If the temperature of reinforcing steel in RCC structure exceeds 500 to 600 degrees Celsius for a time above 1 hour, it will result in failure of structure. Physical characteristics of rebar. Yield stress. It is the material property at which the material begins to deform. In the diagram, point C is the point from which the material starts to get deformed, and at point D, it fully gets deformed. Ultimate stress point. is the maximum stress that a material can withstand while being stretched or pulled before breaking. Here, we can see that E is the point which is the ultimate reading of the stress. Further increment in loading will break the material. Breaking point is the point at which the material will get break. In the diagram, the point F indicates the breaking of the material. The permissible minimum yield strength of the steel is 500 Newton per millimeter square, and the minimum tensile strength is 10% more than that of yield strength. The density of steel is 7,850 kg per meter cube. In order to calculate weight of the particular bar, the formula is volume times density, which for a bar will be as highlighted. For a 10 mm diameter bar, unit weight will be 0.616 kg per meter. In same manner, the weight of the plate can be calculated. Carbon percentage in bars with D is lower. This improves the ductility and weldability of steel. Higher sulfur content leads lower melting point of steel, leading to failure under high temperature conditions. Higher phosphorus makes the steel becomes brittle under extremely cold conditions and leads to cracking.